All right, let's take a look at our lesson for today. So today we're going to be looking at right triangle trig. Isn't that exciting? Okay, so you are familiar, we've been talking about right triangles. We did a little bit of work with that last time. They want us in this case to find the value of x for the right triangle. Okay, let's think about that. So we want this value and we have 60 degrees. Let's think about what trig could we use. Let's see, this would be adjacent. So we need a trig that uses adjacent, and we have the hypotenuse. So adjacent and hypotenuse. So what would that be? Let's see, so cosine, yep, cosine. Cosine of 60 degrees equals adjacent, which is x, over hypotenuse, which is 8. Now we've been doing a lot of unit circle work, so let's kind of dig back in our memories. The 60 degrees, this is a unit circle value. We're going to do one with the unit circle value and one without. So 60 degrees would be one of the 30/60/90s, which is right here. It's the taller one. So if you recall the coordinate points that go with that, that would be what? That would be 1/2 √3/2. All right, now do we remember which does cosine go with, the x or the y? Yeah, this goes with the x. So we're going to replace cosine 60 degrees with 1/2 equals x over 8. So doing our cross multiplication, we get 2x equals 8, or x is 4. Okay, so we solved for x. Great. Now on this next one, we really are, it's not a unit circle value. Okay, so we're going to have to use our calculator. So I'm going to pull up my calculator in just a second. We're going to set this up first so that I can show you, make sure we're clear on how to input it in our calculator. But when they say solve, hey, my calculator just popped up. Wasn't that nice? Okay, when they say solve a triangle, what they're talking about is finding all of the missing parts, like whatever angles you don't know, whatever sides you don't know. That's what they want you to do. That's what solving means. So let's kind of get some work done on that. What do we need to do? Let's see. Well, here's the angle that we have. It's 28 degrees. I think it doesn't really matter what we do first. What if we deal with this y value first? So I need hypotenuse and adjacent. Let's see, which of the trig functions deals with hypotenuse and adjacent? Cosine. So we're going to say cosine of 28 degrees equals adjacent, which is 15, over hypotenuse, which is y. And that's what we're trying to find, is what is the hypotenuse. So we cross multiply. We're just going to solve for y. So y is going to be 15 over cosine of 28 degrees. All right, so let's get our calculator. So remember now, we go up here to the top and make sure it's in degrees. So this lesson is in degrees for our triangles. Of course, triangles are degrees, right? We got to deal with that. Okay, so we had so what was it? It was a fraction. Let's see what we were doing. So we need 15 over cosine 28 degrees. That's what we're doing. So let's do our fraction first. You probably know how to do that. It's that blue button here is a fraction. Yay. Blue button and then the division sign. And so it was 15 divided by cosine. Remember, we have to punch that trig button. Cosine of 28 degrees. And recall, we have to hit Control Enter, not just Enter, to get the decimal approximation. So side y, or the hypotenuse y, is 16.9886. All right, so let's go back and put that down. So y is, and we'll round it, 16.989. Okay, great, got that one checked off. Let's work on the x one. Let's see, x, again, we're dealing with 28 degrees, so x is opposite. So we want opposite and we have adjacent. Let's see, what would that would be tangent, right? Tangent of 28 degrees equals opposite, which is x, over adjacent, which is 15. So x is going to be 15 times tangent of 28 degrees. So we go to our calculator. we put in 15. Remember, you have to hit the times button because the calculator's fussy. Times, and then tangent of 28 degrees. And remember, we have to hit the Control Enter, or it just gives us back what we gave it. So 7.9756. All right, so let's go and let's round that. So our x value is 7.976. Okay, good. We're making progress. We've got actually our sides done. The only thing left is the missing angle measure. But we can do that, you know, like old school, right? Because we know that a triangle all adds up to 180. So I've got 90 plus 28. Let's see how many angles we've used so far. 118 degrees. So we do 180 minus 118, and that gives us our 62 degrees. So angle Z is 62 degrees. Okay. So that's a little bit of a precursor going into our word problems. So let's go to the next page. We have just a couple of word problems to work with, and let's see how that goes. So, okay, so we have a light keeper observes that there's a 30-degree angle of depression. Now, you may not have dealt with angle of depression before in any of your classes, or angle of elevation, so we will talk about that as we draw the picture. So that is a thing. So the angle of depression between the horizontal, by the way, it's always with the horizontal, and his line of sight to the ship. Okay, if the keeper is 19 meters above the water, how far is the ship from the shore? Okay, so let's draw our lighthouse. Okay, so don't make fun of my lighthouse. It's not a great lighthouse. So there's my lighthouse. There's a light. Okay, so he is 19 meters, so he's like up here in this little place right here, and that's 19 meters. That's tall. And we've got a ship out here. Okay, that's a great looking ship. So we've got a ship out here, and it says that he observes there's a 30-degree angle of depression between the horizontal. So what do we do the horizontal by where his line of sight is. We like look straight across. That's the horizontal. And then we draw, he's looking, so there's the ship. Okay, so the 30-degree angle of depression between the horizontal and his line of sight, that means that that's this little angle right in here. That's 30 degrees. All right, let's see, what else do we know? How far is the ship? So this is what we want to know. How far is the ship from the shore? So we're going to call that X. Okay. Now, let's think. We need to get like something inside the triangle, right? We've got that 30 degrees. It's kind of like hanging out in the air. We need it inside the triangle. So we're going to have to dig back into our geometry memory. Yay. So do we remember two parallel lines cut by a transversal? Yes, of course. So you remember that that the alternate interior angles are congruent. So we got the 30 degrees, and so that means that's 30 degrees. Now we have, and we know this is a right triangle. Okay, so we're making progress. So we've got this angle, we have opposite, and we want adjacent. So what should we use? We have opposite and we want adjacent. Yep, tangent. So tangent of 30 degrees equals opposite, which is 19, over adjacent, which is x. So let's solve for x. So cross multiply, so x tangent 30 degrees equals 19. So x is going to be, let's see, 19 times x. Okay, so x is going to be what? It's going to be 19 divided by tangent of 30 degrees. Okay, so let's do that in our calculator. Opposite over adjacent, yep, 19 over adjacent was x. Okay, so let's go to our calculator. We're going to do a fraction, so control division gives us a fraction. And so we've got 19, I think that's, let's make sure. Yep, 19 over tangent 30. So 19 over tangent, so tangent of 30 degrees Remember, we have to hit Control Enter because we have to. So that gives us 32.909. Now, tangent of 30 degrees is a unit circle value. We certainly could have used the unit circle if we wanted to. That would have been fine. I mean, we used a calculator instead, but we could have used the unit circle. What was that? 32.909. Okay, so x, the distance, is 32.909, and what's our units? Let's see, meters. So the ship is a little over 32 meters from the shore. All right, one more, we got this. 20-foot ladder is leaning against a building. Okay, so here's the building. There's the 20-foot ladder. If the base of the ladder is 6 feet from the building, okay, so 6 feet from the building, what is the angle of elevation? Oh, another great word, angle of elevation of the ladder. Oh, and how high does the ladder reach? Okay, angle of elevation of the ladder. Okay, so what that's talking about, we always measure with the horizontal. So it's talking about this angle right here, the angle between the ladder and the ground. That's the angle of elevation. So we need that angle measure, and we want to know how high the ladder reaches up, so we're going to need this side value. So we have another right triangle, and we just need to find an angle and a side measure. Well, let's tackle the side measure first, right? That's just Pythagorean. That's going to be great. So we've got, what, y squared plus 6 squared equals 20 squared. So y squared equals, what is 20 times 20? Is that 400? Minus 36. Okay, so y squared is going to be, what is that, 364? Okay, now we know it's a plus or minus, but we're talking distance, so it's just plus. So it's the square root of 364. Now our calculators will simplify that for us, which is kind of super fun. If we just type in square root of, where's the little square root guy? There he is. Square root of 364 and hit enter. Yeah, it's 2 root 91. Fancy calculator. All right, so y is 2 root 91. And are we heavy? It's feet. Okay, so we've got how tall the ladder is up the building. So the last thing we need to do is figure out the angle measure. Okay, angle of elevation. Let's think about this. So we want that angle, and we have adjacent, and we have hypotenuse. I don't really want to use that that we just figured out. I don't want to use that. What if I made a mistake? We're just going to use the numbers we have. So let's see, what trig function uses adjacent and hypotenuse? Yep, cosine. So we don't know theta, so cosine theta equals adjacent, which is 6, over hypotenuse, which is 20. Oh, this is new uncharted waters for us. How in the world are we going to find that angle measure? Well, I'm calling it theta. You could call it other things like x or whatever, but we'll call it theta. How would we solve for theta? So this is a new concept we haven't talked about before yet, but we will. Our next lesson is on inverse trig functions. Basically, you know that, like, if I take 2 and multiply it by 3, that would give me 6. And then if I divide by 3, it takes me back to 2. You know how multiplication and division are like undo each other? Well, that's the same thing with cosine and inverse cosine. They undo each other. So on our calculator, it looks like cosine to the -1. It's a weird, like, little -1 thing. And when we were going over it, I was showing you, yeah, this bottom row we haven't talked about yet. Ooh, we're talking about it. So we're basically just solving for theta. So what do? We do the same thing to both sides. We're going to, and I call it arc cosine. We'll get into that more, but we'll just do your calculator. We'll do arc cosine of each side. So arc cosine of cosine gives me theta, and then we're going to have cosine to the -1, which is arc cosine of 6 over 20. And this is just something we're going to put in our calculator. Okay, we want it to be in degrees because these triangles are in degrees, right? When you learn triangles, you learned in degrees. So let's put this in our calculator, inverse cosine of 6 over 20. All right, so here we go. We're going to go to the trig button. See the little, on the bottom row, they're all like inverses or the little negative ones. So inverse cosine of, and we're going to put a fraction there because I want to use the fraction thing. I like it. 6 over 20. And I'm going to do Control Enter because I don't want any funny business. So it is 72.542 degrees because see, we're still in degree mode. So let's go back over here. So our angle measure, our angle of elevation is 72.542 degrees. All right, and there is right triangle trig.